Okay, so my error was I was taking the absolute or the facade height as this value, and I'd already calculated that new facade height in the formula here. So I was using panel height, which was just the number from 0 up to here, but my implications here was I was taking the overall height with the inclusion of the podium. So I I had the wrong height input, so I corrected that, and now we're moving along fine. So if I change the height, you'll notice how the midpoint or the curve stays within the center of that whole element, no matter what we do with the height of the podium or um, the overall facade height. Okay, so let's now look at the one other element, and that is to create a draw here. Actually, we might just jump a little bit ahead so you can see where we're going here. Let's add the idea of a surface to this. And I'm going to just jump out to see how I did this in the example I've been working on. So we're going to actually do a surface by loft. Surface by loft. And that takes an input of cross sections. And we have 3 cross sections. So we're going to try and generate the surface from these 3 cross sections. So we need to gather those up. So we need to do a list create. And it's important that we think about the order here. So our bottom one is this one. Our top one is this one. And our mid one is up here, this NURBS curve here. And if we fill this into the cross section, we get our surface generated. All right, so the last thing we want to do now, as far as just the generation of the surface to be manipulated with inputs, is to do this idea of a draw, to be able to pull this bottom element back a little bit. And in this example, I have already created the slider draw. And we'll make a new code block. And so the idea here is this is our width, our face width, and we're going to just shorten it by this draw, this subtraction of that element. So we'll just type in width minus draw, and we'll put in the width, and we'll put in the draw, and we'll make that our x value down here. So right now, our x value of our terminal point here, if I highlight that one, you'll see that point goes on, is there, and we're really just going to modify that with a new x value. And now that's pulling that curtain back, and that actually looks pretty neat in this case. So now we can adjust the draw of that curtain by changing these values. All right, so to keep our clips balanced off, why don't we now go ahead and look at kind of panelizing the surface. And this is where we're going to introduce really a tool that was developed for Grasshopper and has been adopted by Dynamo or implemented by it. And it's Lunchbox. It's a whole bunch of, excuse me. And I'm hoping they'll pop up here. Well, there's one Lunchbox. Let's try Lunchbox quad. All right, there we go. So here's what we want. Lunchbox, and it's a panel quad. The idea is that we're just going to make up 4-sided panels. And we need to divide off that. And instead of XY grid, because this is now a curvilinear geometry, it's defined in U and V components. So we're going to make two numbers. And we're going to actually adjust these numbers will be kind of crude to start with, so we get quicker redraws. So let's say we're going to make it 12 for one of them, and I'll make it 6 for the other one. And we're going to go ahead and plug that surface into it. And that's going to subdivide our surface into both panels and points. And I used the wrong one, but it's not really going to matter for this example compared to the one that I had done before. Let me turn off the surface. Turn that preview off. And we're not seeing the lines between these, but let me zoom in here. And if you look, this has now been, was 12 along that way, 6 along this way, and each one has 4 points to it, and it's panelized that surface. So these are actually now flat planar elements applied to that curved surface. And you can even see the original curve now and how that deviates from that. So now at any point that we kind of up the resolution, so to speak, so if I went to 36, let's say, and 12 this way, and this will take us longer to recalculate. So that's what the screen redraw is. And there we go. We have now a much, I think that other one is getting input too, so we're going to need to wait for that to also redraw. So that was, I increased it both vertically and horizontally as far as the number of panels. And of course, after going through this tedious redraw, I'm going to go back and set those numbers down so as we move forward we can accomplish tasks in a little shorter fashion. But I'll give this a second to redraw. And there we go. Now we have a much finer resolution of panels. And even at this level, you can start to do a study for how many elements might be considered sufficient to communicate that idea of what's happening with our shape geometry. So you get the idea here. It's a little hard to tell in this view. Maybe if I roll this over a little bit. All right, you can see what's going on with our geometry here. So this is a very robust change in the shape of the surface. And probably once we get into rendering it and drawing that, this is way more than we really would want to do as far as amplitude goes. So we could, once again, I could go back and change that amplitude, and I encourage you to experiment with it. But I'll save you the time of waiting for the redraws, and we'll end this clip and pick up a new task on the next one.